Okay, so today's notes are on using linear models. So it's section 2.5. Our content objective is going to be to write linear equations that model real world data and make predictions using linear models. So instead of using a very clean set of data that where it follows a perfect line, we're going to have some scatter plots and things that make it a little bit different, that actually seem more like real situations. And then our language objective is going to be to define things like linear model, scatter plot, correlation, which we'll talk about strong, weak, negative, and positive correlations, and then trend lines. So let's jump right in and talk about scatter plots because that's sort of the point that all of this stems from. So scatter plots or a scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. So you may have seen a scatter, or you've most definitely seen a scatter plot before, whether you called it that or not, but it's just a set of points on an XY plane. So a scatter plot is just a set of ordered pairs on an XY plane, simply put. What we're going to focus on today is not scatter plots that might look like this, where it's sort of random and there's just points everywhere, but we're going to focus on more on scatter plots that demonstrate some sort of correlation. So the correlation is the strength of the relationship between data sets. So I'm going to draw 4 different examples in the bottom part of this page. The first I'm going to show us is a strong negative correlation. So the first one, we have our XY plane, this is our y-axis, our x-axis. A strong negative correlation means that the points are going in the negative direction, so they're going down as x gets larger. And they're pretty closely along an imaginary trend line that is going in the negative direction. So since all these points are pretty close together following along this imaginary trend line going downwards, this would be a strong negative correlation. We can also have a weak negative correlation. And this, if we again draw our XY plane, would again be trending in the negative direction, but it would not be as closely knit along one line. So again, if you look at these points, again, generally they're going in the negative direction, but they're not as tightly knit around a imaginary trend line. So they're still trending, but not as closely trending as the previous set. And we can also have positive correlations. So, sorry, I wrote this in the backwards. It should be strong positive correlation. Sorry, I wrote positive first. So strong positive correlation, again, if we draw our axes, they would be closely knit going in the positive direction. So again, positive, closely knit, strong positive correlation. We can also have a weak positive correlation. And that would be similar to the weak negative correlation, but only the positive direction. So again, these are trending in the positive direction, but they're not as tightly knit around that trend line. They're a little more spaced out as they trend in the positive direction. So these are the 4 types of correlation that we will work with when we're doing these things. And we're going to use these correlations to build trend lines. So I'm going to flip the page so we can talk about trend lines. So a trend line is what we're about to build in our next example, and this is a line that approximates the relationship between variables or data sets of a scatter plot. So if you remember, the second half of our objective refers to making predictions using trend lines or linear models. And so we're going to create trend lines from our scatter plots that will help us make these predictions. And later in math, you'll get more precise with it, but for now, we're going to talk about more imprecise trend lines in our next example. So our example says the following data set shows the median home prices in Florida. What is the equation of the trend line that models a relationship between time and prices? So once we come up with that equation, we're going to use the equation to predict the median home price in the year price in 2020. So we got to write down our data set first. So we're going to start with the year and then the price. I'm going to write my table horizontally. So we have our year and our price, and we start in the year 1940, and the median home price is $23,100. Then in 1950, we have $40,100. In 1960, we have $58,100. In 1970, we have $57,600. In 1980, we have $89,300. In 1990, we have $98,500. And the last year they record is 2000, which is $105,500. So this is our data set. And the first thing we're going to do, so I'm going to write our steps off to the side. So step one is to make a scatter plot. So I'm going to talk through some of the tips I have for drawing a grid. Obviously, it would be ideal if you guys were doing this on graph paper. I'm going to do it in the notes with lined paper for now, but again, keep in mind, graph paper would be ideal. But I'm going to assume my top value is going to be 120,000. So I'll put that there because I know it's going to be more than 105. So I could do 110, but just to be safe in case I want to graph higher later, I'm going to go by 10,000. So that would be 110. This would be 100,000. And then 90, and then this would be 80,000. 70, 60,000. So you can write in every amount, but I think it's easier to do every other. So 50, then 40,000. Skip one. This would be 20,000. and then 0 is here. So that's my y-axis, and I note that I didn't go below 0 because I'm not going to have home values worth negative amounts, so I'm starting at 0, and I need to label my axis. So this is the price of homes, and the units is dollars, so I put price, I put my units in parentheses. My x-axis is going to be time. Instead of putting 1940, 1950, since I'm starting at 0, I'm going to label this axis as years since 1940. So 1940 is going to be my year 0, since that's where we're starting. And then I'm going to go by 10 years. So I have 10, 20, extend this a little bit further, 30, 40, 50, 60. So this was 1950, 1960, 1970, 1980, 1990, and then 2000 would be 60 years since 1940. So I'm going to stop my graph there for now. Now it's just a matter of plotting these points on the grid. Since they're not, since our units are kind of spread out, it's going to be somewhat imprecise, but I'm going to do my best job to make it as precise as possible. So I'm going to say right about there is 23,100. At 10 years, it's going to be just above 40,000, right about there. At 20 years, it's going to be 58,000, so it's going to be a little bit below 60,000, so I'll put it right about there. 30 years, it's going to be a bit less than that, so it's going to be right about there. At 40 years, in 1980, it's going to be at 89,000, so it jumps up quite a bit, so just below 90, right about there. 50 years in 1990, it's 98,000, so it's just below 100,000. And then at 60 years, it's going to be just above 100,000. So right about, or between 100 and 110, so right about there. So those are my points all plotted on the scatter plot. Again, I was trying to be as precise as I could, but it's not perfect, especially since it's not on graph paper. So the next thing I'm going to do, step 2, is going to be to sketch a trend line. And it's important that I get at least 2 points. On the line. So if you guys recall, to write slope, I need to have at least 2 points, or to calculate slope. So when I'm going to use a ruler now to make sure I'm getting 2 points in there. But I want to make sure I get at least 2 points so that I can sketch my trend line. So, and I want it to be somewhat between somewhat approximating the points that we have. So here I would get this point and this point, so I'm going to go ahead and draw this line, and it goes a little bit above the first point, but then it hits those two, so that will work for now. So this is my trend line that I've just sketched, and if you didn't use a ruler, that's okay, but as long as you're hitting at least 2 points and making a general trend line, that will work. So the next thing I'm going to do is choose 2 points to write my equation. So I'm going to choose 2 points and write the equation of the line. And I don't quite have room on here, so I'm going to note that I have this point, which is at 10 years in 1950, and this point at 50 years, which would be 1990 at that point. So those are my 2 points. I'm going to flip it over and write that so I can have space to finish my work. So make sure you have all of this down before I flip the page. All right, so if you didn't catch that, point 1 was after 10 years, and the median home price was 40,100. And the second point, point 2, was after 50 years, and it was 98,500. So these are my 2 points. I'm going to write the equation of my line. So I'm first going to calculate slope, which we use m to represent. So change in y is going to be 98,500 minus 40,100 over 50 minus 10. So those are my 2 coordinate points. I'm going to calculate it out. So I end up with 58,400 over 40. And if I plug that into my calculator, if you didn't do that out in your head, that's fine. You could do that on a calculator, but then I do 58,400 divided by 40. And I get 1,460. So my slope is going to be 1,460. And I'm going to substitute it into point slope form since I have 2 points and my slope. I think that's the easiest one to plug it into. So I'm going to do y minus, I'm just going to choose 0.1, 40,100 equals m, which we know is 1,460 times x minus 10. So there's my equation of my line. If I wanted to rewrite it in slope-intercept form, I could do that. But for now, I'm just going to pause. And since the other part of our question, if we flip back real quick, asked us to predict the price in 2020, I'm going to use my equation to predict the price in 2020. So step 4, I believe it is, yep, is going to be substitute 80 for x. And the way I got that, just to back up real quick, I know I'm talking about the year 2020, and I started in the year 1940, so I'm trying to figure out how many years passed. And if you subtract those out, you get 80. You could also just continue counting up on our table. So we know this was after 60 years, so 2010 would be 70, so 2020 would be 80. If you continued that pattern, so we know we're substituting 80 for x because it's 80 years after 1940, and calculating out. So if I substitute that in, I get y minus 40,100 is equal to 1460 times 80 minus 10. So when I plug that in, 80 minus 10, I get y equals 1460 times 70, and I'm adding the 40,000 to the other side, plus 40,100. So I did 2 steps right there. I simplified this and I added that to the other side just to make sure you're on the same page. If I plug that in, I get 1460 times 70, which gives me 100,000 or 102,200. So y, just to show this step, and then I add them. So plus 40,100, and you get y equals 142,300. So in 2020, to summarize our answer, the median home price will be approximately or about or around $142,200. So that is our prediction that we made using our trend line. All right, make sure you write down any questions, comments, concerns, or clarifications on this stuff so we can go over it together in class.